right, so this is notes for 4.4 part 2. In your packet it might say part 1. I think I forgot to change it to part 2 because we added in a part 1 so that we could practice more factoring. How do we know when a polynomial is factored completely? Well, this is going to be when the polynomial is written as a product of unfactorable polynomials. So once we get this down to the point where we cannot factor anymore, that means that it is completely factored. Factoring by grouping, we talked about this. We're going to use this when there are pairs of terms that have a common monomial factor. We did that yesterday. Any quadratic that's in this form AU squared plus BU plus C, usually we use X's, that's quadratic form. We're going to learn some new factoring types today. We're going to learn how to factor the sum of two cubes and the difference of two cubes. Now, there's a formula for this. Our book likes to say that, we have these two different formulas. But let's look at what the pattern is. If I have something cubed here, we're going to take the cube root. That goes in the first parentheses. We always match the sign up, and then we have the cube root of this number. In this one, we have the a value squared minus the product of a and b plus b squared. Look at this example. What is the cube root of 64? 4. So in this case, a would be 4x. What is the cube root of 1? 1. So here's our a, here's our b. We just plug it into the formula. It's going to go 4x plus 1. We take the a and we square it, and we get 16x squared minus a times b plus b squared. That's the formula. If we have the difference of two cubes, here's the pattern. We do the cube root again, match the sign, b, then it goes a squared. This is always the opposite. So if this is minus, this is plus. If this is plus, this is minus. Then the last one is always positive. Why do you think that might be, that the last one's always positive? What is anything squared? Positive. So that's the reason why this one always ends up being positive. And so looking at an example here, what is the cube root of 27x cubed? What's the cube root of 27? And what's the cube root of x cubed? Okay, now for b, what is the cube root of 8? And now we just apply our formula. So it's going to go a minus b, a squared, opposite sign, so it's plus ab times b, or plus b squared. Okay? I always memorized it like this because I just want one formula to memorize instead of two. Look at it, guys. It's a cubed plus or minus b cubed. The formula goes a plus or minus b, but in this parenthesis, remember how these are always the opposite? So if this is a plus, this is a minus. If this is a minus, this is a plus. And then I said this one's always positive. Okay? The sooner you can remember this, the better. Let's practice without looking up above. These are perfect cubes. So what is the cube root of 1,000? And the cube root of x cubed? What's the cube root of 27? So now using our formula, it's going to go a, match the sign, plus b. Now the second parenthesis is going to be a squared. So what do I get if I square that? 100x squared. What's the sign going to be? Minus, what's a times b? 30x, and then plus b squared. What do I get? 9. So if I were to multiply all this back out like we did before, I would get this back again. That's what we're doing. We're factoring it. So these two multiplied give us this. All right, let's do this one. What's a going to be? What's b going to be? 5y squared, good. And that's because y squared times y squared times y squared would give us y to the 6th. So that's the cube root. All right, see if you can write it out now. Look up here and see if you got it right. 2x minus 5y squared times 4x squared plus 10xy squared plus 25y to the 4th. How many people got it? Awesome. All right, let's go on and practice a few more. We will not be doing all of these, but we are going to do a few. And the reason why is because of this word completely. Yesterday, what did we talk about that we should always look for first? GCF. What's the GCF for 20, 220, 600, and everything else? 20x. So I factor out a 20x. Dividing this, I'm going to get x squared. Dividing this, I'm going to get minus 11x. Dividing this, I'm going to get 30, yeah. Now, to see if this is completely factored, I have to check this one. Are there numbers that multiply to be 30 and add to be 11? Yeah. Yes, so this can be factored further. Does anyone know how that factors? Good. And now it is completely factored. There's nothing more we can do with it. All right, let's do number 2. This is a little bit different. What's the GCF? So I take out an m, and I'm left with m to the 4th minus 81. When we have two terms, remember how we have to check and see if we have the difference of two squares? Are these perfect squares? Yeah. So this is going to go down to m squared plus 9 and m squared minus 9. Because this is the difference of two squares. Now, this and this are completely factored, but this is also what? Difference of two squares. So I have to carry down this. I have to carry down my second factor. And then how does this one factor further? Good job. All right. Look at number 3. Which type is this? Sum of two cubes, right? Without looking back, can anybody do it? Give it a shot. What do you think? Raise your hand if you think you can do it. All right, go ahead, Drew. What do you think? Okay. What do you think, Josh?
3a plus 2b is 9a squared plus 6ab plus 4b squared.
Very good. The only thing you said wrong was this sign right here. It always has to be the opposite, but that was very nice. Good job. Okay. What do you guys think we're going to be looking for on number 4? Yeah, we can do a GCF first. So what is the GCF? T to the 3rd. I'm going to take that out first, and I'm going to have 5t to the 3rd plus 2t squared minus 5t minus 2. Now, what do I look for when I have 4 terms? Grouping. So I'm going to look at these two, and I'm going to look at these two. So t to the 3rd is going to come down. Now, times. What can I factor out of these two? t squared. Now I'm just going to keep this in mind. This really isn't a part of what I'm doing now. I'm going to kind of scoot over a little bit. So I'm going to take a t squared out of here, and I'm left with 5t plus 2. What am I going to factor out of here? -1, and I'm going to have 5t plus 2. Now, I've already got the t cubed, and what can I factor now out of these two? So I'm going to factor out a 5t plus 2, and what am I left with? T squared minus 1. And I'm still not finished because what is this one? Difference of squares. So now the final answer would be t cubed times 5t plus 2 times t plus 1 times t minus 1. So you got to keep going with this. Now, I always like to check this at the end when on these long ones. T cubed times t times t times t is how many t's? T to the what? And look at this, t to the 6. See, I just want to make sure I didn't leave one out. It's really easy to forget one on those long problems. Okay? All right, let's see. Let's go down. We'll go ahead and do number 7. Let's go down to 7. What's the GCF for this one? Definitely what? We've got zeros, so definitely 10. We're going to factor out a 10, and I'm going to have 81k to the 4th minus 16. What are these going to be now? The difference of what? Difference of squares. So now I'm going to have 10, and this is going to go down to 9k squared and 9k squared. And what's the square root of 16? So this is going to have to be plus 4 and minus 4. Would I now be finished? Nope. I bring down the 10. I bring down this one because this is the sum of two squares. If it's plus, guys, it can't go down any further. It can't factor down. But can I factor this one down? Yep. What is it? Good job. All right. Let's see. Number 8 is very similar to number 4, so I'm not going to do that. We did a lot of those yesterday with the 4 terms. Let's go down here to number 9. Let's look at number 9. What's the GCF here on number 9? 2x to the 4th. We're left with x squared minus 4x minus 21. All right, you guys finish it. Check your answer up here. Did you get it? X minus 7, x plus 3. Don't forget the first one that you factored out. See, now I check it. X to the 4th times x, x to the 6th. We're good. All right, we'll just do 11 and 12 and we'll be finished. Okay, out of here I can take out a 3n squared and I'm left with, oh, that's an m, not an n. 1 minus 16 m to the 4th. All right, so what is this one now? When I have two terms, I'm looking for what? Difference of squares. Bring down the 3m squared. This is going to be the square root plus the square root. And then the other one is the square root minus the square root. Is there more we can do? Yep. This stays the same. And this one goes down to 1 plus 2m, 1 minus 2m. Doesn't matter the order I have these. I just want to make sure my power's right. And then I have m's and not n's. 1, 2, 3, 4, 5, 6. Yep, that's my highest power, so I'm good. All right, I'm going to do this one real quick. I'm going to take out an x. I've got 4x squared minus 4x plus 1. Now this one I'm going to have a 2x and a 2x, a 1 and a 1, a minus and a minus. I can write it like this, or I can write it like this as quantity squared.